Okay, I'm going to show you how to replace these three resistors in parallel and change it to one resistor with the same value as these three resistors together. There are two ways we can do this. We can do it the hard way, which I'm going to show you now, and then I'm going to show you the easy way. We know that the formula is 1 over R total is 1 over R1 plus 1 over R2 plus 1 over R3, or we can also write RT equals 1 over R1 plus 1 over R2 plus 1 over R3. Seems kind of complicated, but it's not so difficult. So we're going to calculate that resistor RT equals 1 divided by 1 over 10 plus 1 over 20 plus 1 over 30. Okay, now we're going to calculate this here. The easiest way to do this is find a common denominator for all these three numbers here. And the easiest way to do is multiply all of them. 30 by 20 by 10, and that always works. But it makes it sometimes a big number, so not so. If you have a calculator, it's easy. So let's say 30 times 20, that's 600, times 10, that's 6,000. That's going to be our number. So we multiplied the bottom number by 600, because 600 times 10 is 6,000. So we multiply 10 by 600, so we have to multiply the top number also by 600. So we have to put 600 here. Here we multiply the number by 300, so we have to put 300 times 1 is 300. Here we multiplied by 30, we multiplied by 200. So 200 times 1 is 200. And now we have a common number. $600 plus 300 plus 200 divided by 6,000 equals 1 over 1100 divided by 6,000. We can eliminate these two numbers here. We can eliminate two zeros here and two zeros there, so we have a smaller number. Now we can flip these two numbers over here. We can flip it upside down like this. 1 stays here, the 60 comes up, times 60 divided by 11. And our answer is 60 divided by 11. 60 divided by 11 is 5.4545. 5.4545. That's the answer. Ohms. RT is 5.4545 ohms. This is kind of the hard way. Okay, now I'm going to show you how to do this the easy way. There is another formula that goes like this: R1 plus 2, this works only for 2 resistors, okay, equals R1 times R2 divided by R1 plus R2. So we can do this only each time by 2 resistors. So in this case we're going to use 1 and 2. So R1 plus 2 equals 10 times 20 divided by 10 plus 20 equals 200 divided by 30 equals 6.666. So now we can change this to our R1 2 equals 6.66, and this is R3. Now we're going to do the same thing again, but with those 2 resistors. R3 is 30 ohms. So R1, 2 and 3 equals R1, 2 plus R3 divided by R1 plus 2 plus R3 equals 6.66 times 30 divided by 6.66 plus 30 equals 199.8. divided by 36.66, and the answer is that should be 5.4545. So let's check it here. 199.8 divided by 36.66, 5.45. We have the same answer. Now there is a trick that you can use. Oh, now remember that the answer is always smaller than the smallest resistor. Let's make an example here. 10 ohms and 10 ohms. And we have 5 ohms. When you have 2 resistors and they have the same value, the replacement of those 2 resistors is half of 1. So 10 ohms and 10 ohms, that would be replaced by 5 ohms. And we have another 5 ohms here. Five ohms and 5 ohms, they're all the same value, so the answer to the replacement resistor is 2.5 ohms, half of 5. So the answer here would be 2.5 ohms. It's the same as this one. Now let's calculate it. 10 times 10 divided by 10 plus 10 is 100 divided by 20 is 5. So this 2 becomes 5. Now let's calculate 5 and 5 and see the answer is 2.5. So 5 times 5 divided by 5 plus 5 is 25 divided by 10, and the answer is 2.5. See? And the answer is always smaller than the smallest resistor. See, 2.5 is smaller than 5. So if you have a number, a replacement resistor, and you come up with a number that's higher than the smallest number, then there's something wrong with your calculation. So the answer is always smaller than the smallest resistor in your circuit.